students, today we will learn about water.
In this chapter, we will learn about chemistry of water, removal of hardness in water, purification of water. We will also learn about hard and soft water, chemical properties of water, and the action of water on metals and steam on non-metals, and also the reaction of water with metallic oxide. We will also learn about deliquescent substances and efflorescent substances. You know that water is one of the most abundant and important compounds in the world.
The human body has about 65% of water. Neither plants nor animals can survive without water. Purification of water. Traditional methods of obtaining potable water include the following: boiling, exposing it to sunlight, adding tulsi leaves, dropping red hot iron balls.
There are different methods for removal of color, odor, suspended matter, and microbes from water. In addition, there are many methods for removal of hardness. Water treatment includes stages of coagulation or sedimentation, filtration, decolorization, deodorization, and sterilization. Alum is used for sedimentation.
You have studied physical properties of water in the previous classes. Now, let us learn more about the chemical properties of water. You know that chemical formula of water is H2O. In a water molecule, one atom of oxygen is bound to two atoms of hydrogen, as shown in the figure. Water is called universal solvent because it dissolves more substances than any other solvent. Dip a piece of blue or red litmus paper in pure water. What inference do you draw from this activity? Action of water on metals. We store water in different metallic containers. We also boil water in metallic containers. Does water react with any metallic container? Metals like copper, aluminium, and tin show no reaction with water at ordinary temperature. Many metals and their alloys are used to prepare utensils, buckets, kitchenware, and other articles because they do not react with water under normal conditions. Sodium and potassium are soft metals and can be cut with a knife. They react with water, forming their respective hydroxides, liberating hydrogen gas, hence they are kept in kerosene. Take a clean piece of sodium. Dry it using blotting paper. Cut a small piece of it about the size of a green gram dal. Drop it carefully into water taken in a beaker. Notice that the sodium piece moves randomly on the surface, reacting with water violently. It gradually diminishes in size and finally disappears. It reacts with water, forming sodium hydroxide and hydrogen. Test the resulting liquid in the beaker with blue and red litmus paper. The solution is basic. Metals like sodium and potassium react with cold water, forming respective hydroxides, liberating hydrogen gas. That is, 2Na plus 2H2O gives rise to 2NaOH plus H2. Other metals also react with water at different conditions. That is, Ca plus 2H2O at room temperature gives rise to CaOH2 plus H2. And the other reaction is Mg plus 2H2O gives rise to When steam is passed over red hot metals like zinc, iron, magnesium, we get respective oxides and hydrogen gas. That is, Zn plus H2O gives rise to ZnO plus H2. 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Mg plus H2O gives rise to MgO plus H2. Action of steam on nonmetals. When steam is passed over red hot coke, a mixture of carbon monoxide and hydrogen is formed. That is, C plus H2O in the presence of heat gives rise to CO plus H2. The mixture of carbon monoxide and hydrogen in the ratio of 1:2 is called water gas. Uses of water gas. It is used as an industrial fuel and used in the manufacture of hydrogen, that is Bosch process. Acid rain. When nitrogen dioxide, carbon dioxide and sulfur dioxide present in the atmosphere of certain industrial areas dissolve in rainwater, they cause acid rain. That is, SO2 plus H2O gives rise to H2SO3. 3NO2 plus H2O gives rise to 2HNO3 plus NO, and CO2 plus H2O gives rise to H2CO3. Hard water. Water is a very common and suitable solvent. Some impurities dissolved in it very easily. Mostly, soluble salts of calcium and magnesium make water hard. As the percentage of calcium and magnesium increases in water, the degree of hardness also increases. Hard water does not produce much lather with soap. Soft water. Soft water produces a rich lather with soap. Rainwater and spring water are examples of soft water since they contain very small amount of dissolved salts in them. Methods of removal of hardness of water. Hardness of water can be removed by two methods. If hard water contains calcium and magnesium bicarbonates, it can be made soft by boiling. In this reaction, calcium bicarbonate decomposes to insoluble calcium carbonate and carbon dioxide. Example, CaHCO3 in the presence of heat gives rise to CaCO3 plus H2O plus CO2. Hardness can be removed by the addition of washing soda to water. In this reaction, the soluble salts of calcium and magnesium are converted into insoluble carbonates. The soluble sodium salts do not cause hardness. Examples, CaCl2 plus Na2CO3 gives rise to CaCO3 plus 2NaCl. CaHCO3 plus Na2CO3 gives rise to CaCO3 plus 2NaHCO3. CaSO4 plus Na2CO3 gives rise to CaCO3 plus Na2SO4. Experiment to show the removal of hardness of water by washing soda. Materials required are beaker, glass rod, washing soda or sodium carbonate, hard water. Take some hard water in a beaker and add a small quantity of washing soda to it. Stir it with the glass rod. Allow the insoluble carbonates to settle down as precipitate. Filter or decant the liquid. Water so obtained is soft, but it is unfit for drinking as it contains excess of washing soda and excess of sodium salts.